Lightweight structures for aviation applications face very strict requirements. New technical developments are made with semi-structural components, like seats. Reduced resource consumption, waste and emissions, and increasing recyclability of components are the main objectives in the development of new manufacturing technologies and the improvement of existing ones.
The increasing number of identical parts and rising price pressure in aircraft manufacturing mean that cost-effective manufacturing technologies are needed. In SMC and wet compression molding process, large components can be produced in short cycle times.
The two technologies of sheet molding compounding and wet compression molding are particularly suited to producing lightweight PU seat structures for passenger aircraft. A weight saving of around 20% can be achieved by tailoring the design to the plastic used. To produce the prototype, our project engineers selected a thermoset matrix system based on polyurethane. The use of only this class of material in the structural parts, adhesive and seat cushions offers significant economic advantages in recycling. The base of the seat is a hybrid SMC component with metal inserts and local continuous fiber reinforcement. The metal inserts are coated with a nanoporous adhesive layer using the PECVD process. For this purpose, we produce C-fiber reinforced SMC with 55% fiber content by weight, using a cutting-edge production line. SMC is processed by compression molding. UD prepreg is inserted into the mold and overmolded with the SMC. This enables the manufacturing of complex component geometries with a high degree of functional integration. Detailed ribs and structures can easily be formed. The complementary component is produced using wet compression molding. The WCM process is a textile-based infiltration process for the production of lightweight and high-performance structural components. The stacked fiber layers are infiltrated with flame-retardant PU resin, then pressing is carried out to form the component.
Low cycle times ensure the cost efficiency of wet compression molding and the robust production of fiber-reinforced plastics.
The two manufactured component structures from the SMC and WCM processes are then joined using a PU adhesive and completed with an intrinsically flame-retardant PU foam and a PU cover.
The seat concept shows significant potential to reduce carbon dioxide through material selection, weight savings, and a circular economy.